In this question, you're asked to build a frequency distribution. You're given data that represents the age of 30 lottery winners. There's a set of data here. We have to read about what we're actually being asked to do with it. If we look at the instructions here, it asks us to complete the frequency distribution using 7 classes. So that's the first piece of information we have. Then we're told to start the lower class at 20, and we're told to use a class width of 10. And when we do calculations, we're rounding to 2 decimal places, if needed. Our classes are these bins over here. So if we think this is our first class, this is our second class, this is our third class, and so on. So we figured out what our 7 classes are. We're starting the lower class at 20. We've done that, and we have a class width of 10. That means if I look at the first class starts at 20, the next class is going to be 10 more than that. So we would add 10 to that. So our class width is 10. So each time we're increasing by 10. And then we have to figure out our upper boundaries on each of our classes. So because we're using integers, we're going to have our upper and lower class limits also be integers. Our data is all integers, and that's what we're going to be using. Because this second class starts at 30, then we need the class before that to stop just before 30, which would be at 29. And then the easiest way, in my opinion, is to say, okay, my class width is 10. So if I end at 29, this one's going to end at 39, 49, 59, and so on. The first job, and I think the easiest way to build this table, is to just go in order. The first thing we're going to look at is frequency. That means how often do these numbers occur. Our first class is looking at all of the numbers between 20 and 29. So if I look back at my data, unfortunately, if you notice, it's organized from smallest to largest. So I look and I see I have a 20, which goes in that class, 27. Actually, I'm going to cross these off as we go along. There are 3 numbers in the 20 to 29 range, so that's a frequency of 3. How many numbers are in the 30 to 39 range? 1, 2, 3, 4. So it'll be 4. How many in the 40? 1, 2, 3. There are 3 here. How many in the 50s? 1, 2, 3, 4, 5, 6. So this is 6, and so on. Cumulative frequency is basically building up, adding the frequencies as we go along. So the first frequency is 3. Now I add 4 to that, so I get 7. Then I add 3 to that, so I get 10. And then I add 6 to that, so I get 16. So I'm basically taking this and adding it, and I get this number. Okay, 7 plus 3 is 10. Relative frequency, you want to think of this as a percentage. So what percent is this frequency out of the whole? Frequency, remember, percentage is part of the whole. Percent equals part of the whole. And our whole in this case is we have 30 lottery winners. So to figure out our relative frequency, if we look at our 20 to 29, I have 3 out of 30. And if we do that on our calculator, you're going to get 3 divided by 30, and you get 0.1. So our relative frequency here is 0.1. And it says round to 2 decimal places, so we are going to put that 0 in there. Let's take a look at let's take a look at this next one. The relative frequency for the 30 to 39 years old age group. That has a frequency of 30 to 30 has a frequency of 4. So this is 0.1. So we have 4 out of 30. And now in this case, we're actually going to have to do a little bit of rounding, because this comes out to 0.1333, and the 3 keeps going on. So this is the same as 0.13 with that's called a repetend bar, saying that the 3 repeats. So if I have to round to 2 decimals, because I have 0.133, this is going to round to 0.13. Because the 3 after, right, the 3 that would be in right here, is less than 5, which means we don't round up, we leave it the same. So this we would leave to 0.13. This one, we're not going to repeat the calculation. 3 out of 30 is the same as our first class. So we're just going to put that's our 0.10. And then cumulative frequency is just adding our frequencies as we go along. So we start out with 0.01. I add to that 0.13. So I would have 0.23 and add another 0.1, so 0.33. And so we're just going to fill out the rest of this table.